Welcome back. This is the first lesson of week 15. This week we're going to learn about a new type of programming method called recursion. In this lesson you'll learn what recursion is and why it is used in programming, and we'll compare it to a type of programming that you're familiar with, the use of iteration. So what is recursion? Recursion is a feature of functions. A recursive function is called from inside the same function. In other words, the name of the function is included as a line inside that function. You might be asked to identify whether a function is recursive. What you need to do is look for the name of the function and then see if that name is repeated anywhere inside the function. This is a recursive function. So why do we use recursion? Remember, a recursive function calls itself. That means that after the function runs, it calls itself and it runs again. The new version calls itself again, and so it keeps on repeating itself over and over again. So recursion is a way of making a block of code repeat over and over again. It's an alternative to using an iterative loop. You can use recursion instead of iteration, or iteration instead of recursion. In fact, a good general rule is anything that you can do with iteration, you can do with recursion instead. There are always two ways of doing the same thing. This example is the one we just looked at. It uses recursion. This example uses a while loop. It uses iteration. So this is the recursive version and this is the iterative version. They both do the same thing. They find the total of a set of numbers input by the user. We've looked before at how functions and procedures use memory inside the computer when they're run. And this is relevant to what happens when we do recursion. Any function opens a new area of memory and local variables are stored in that area of memory. Parameters and return values link the function to the main program. The parameter or parameters pass values from the main program up to the function, and the returned value passes one value back to the main program. When we're dealing with a non-recursive function, this happens just once, so it uses a limited amount of memory. In an iterative function, every time round the loop, it overwrites exactly the same variables, and therefore it doesn't use a huge amount of memory. Now, in recursion, each copy of the function opens a new copy, creating a new area of memory. The values and parameters are passed up the list of copies, and the return values are passed back down the list again. So a recursive function opens multiple copies, each of which is linked up using this stream of parameters and return values. In other words, it uses a lot more memory. So the key facts to remember about recursive functions. A recursive function calls itself. That means the name of the function is inside the function. We use recursion as an alternative to iteration. Why do we use it? In general, it makes slightly shorter and simpler code. Some problems are solved much more simply using recursion, but the disadvantage is that it uses more memory. So let's recap what we've just learned about recursion. You should be confident that you know what a recursive function is. You should know what a recursive function does, and you should be able to evaluate a recursive function in comparison to iteration as a way of solving problems. You should have notes on all these 3 points. If you're not clear about them, go back and rewatch this whole lesson again. So I'm going to leave you with 3 programming tasks, and you can go as far through these 3 tasks as you're able to do. The simplest task is to simply copy the recursive function shown in this presentation, write a main program which calls it, and then run the program to see what happens. If you manage to get that working, try adapting it to create a new function which, instead of adding integers to create a total, concatenates characters to create a string. And if you can make that work, create a new recursive function to find the largest number in a series of numbers. That is a much more challenging program to write. Okay, so in the next lesson, we'll talk a bit more about the structure of a recursive function. Bye for now.